Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I want to give you a code review. And basically what I did was I did like a little work experience with a company called BCG Gamma. And they gave us some type of work to do that they would be doing in their company. And basically, you're not allowed to say you're doing an internship. You're not allowed to say that you are involved at work with them in any way. The only thing I did was just a little bit of type of work that they would do in their company. And I'm not allowed to put it on LinkedIn or social media or anything. But I decided that I would go ahead and do a code review on this. But before I did that, I had to give you the disclaimer to say that it's not work experience. It's not even an internship. You're not allowed to say it's an internship either. So what they did was they gave us two data sets, really. One data set on client data and then another data set on price data. And then we were supposed to analyze those data sets. And so basically what I've done is this is my analysis, the analysis that I personally performed for this exercise, this task that I was given. So we had to do an EDA, exploratory data analysis, on one task. And then the next task, what we had to do was we had to make predictions and we had to use random forest for that. So now that you know what I had to do in that task, I'll go ahead and do the code review. So the first thing that I did was I imported the libraries that I was going to need. So I imported pandas as PD, which creates the data frames, and it creates the data frames and it performs data processing. I imported NumPy as NP, which it creates NumPy arrays and performs numerical computations. I imported matplotlib.pyplot as PLT, which visualizes the data, and I imported Seaborn as SS, which also visualizes the data. And further on in the program, I'm going to import sklearn. So sklearn, what that does is that allows me to split the data set up. And then I also imported TensorFlow, Decision Forest library, which the TensorFlow Decision Forest library has the random forest algorithm in it. So now, after we have imported our libraries, we're going to read the files. We're going to read the client data, and what I did was I set it up pd.setOption display max columns none. So I set it up so I could see all of the columns. So you can see all of the columns here. We checked the shape. The shape was 14,606 by 26 columns. Checked to see if there was any missing values, and no, there were no missing values. And then we checked info, and so this tells you what kind of column each column is. So you've got some objects, some integers, and some floats. Then what we do is we check the statistics of this column. So we use the describe, and so what that does is that gives you the count, the mean, the STD, that standard deviation, min, 25%, 50%, 75%, and max. And then now what we're going to do is we're going to check the price data. So we've got the price data here. Check the shape. It's 193,002 by 8 columns. There's no missing values. And then we check the info. And so you can see that there's 2 objects and the rest of them are floats. We check the price described. So again, you've got your count, your mean, your standard deviation, your min, 25%, 50%, 75%, and your max. I just wanted to check the mean prices. So you've got the mean prices in this price list, and you've also got the average mean prices, which was 10.098. Now what I did, since it was an EDA, I decided to create a scatter plot of the churns. So you can see this is the scatter plot of what the churn looks like. And you can see in this scatter plot that you had a few outliers. Now we're going to analyze the client data frame. And so basically what we're going to do is we're going to check all the unique values in the number of all the unique values in the client data frame, so you can see that. So with each column it tells you the number of unique values that it has. Some columns have more unique values than others. And now what we're going to do is we're going to do a histogram of churn, so you can see that you have a lot of zeros and not very many ones. We check the percentage, so you have 90% didn't churn and 0.097% did churn. Now what we're going to do is we're going to do a pie chart, and you can see that 46.2% were this FOOS, and with a long number, that's your sales channel, and 25.5% they didn't know what sales channel these people were in. So they needed to do something to try to impute these missing values or get more data or go back and find the data. So now what we're going to do is we're going to do a histogram on forecast discount energy. So this is like if they get a discount. So you have like a lot of zeros and a small amount of ones. So a very small amount got a discount. So so you can see that 14,094 didn't get a discount, and then it tells you the people that got the discount thereafter. So, and then you can check the percentage of discounts, and it said that 3.5% of the people got discounts. So that's a small amount. So now what we're going to do is we're going to do a histogram on PowerMax, so you can see the PowerMax. So you can do a value counts on the PowerMax. And so these were subscriptions. These were people who had a subscription. And so 13.2 was the highest amount, was the most frequently used number, whereas 10.32 was the second most frequently used number. So it said that 100% of the people got a subscription of some sort. So now what we're going to do is we're going to do feature engineering, which is the second part of the task that I was given. So they gave us the way to do the feature engineering. So the first thing that you're going to do is you're going to take the date and you're going to convert it to a date using pandas to datetime. So, and then we're going to do a value counts on the price date, and then so and what that does is that tells you how many months that the price covered, and I counted it up and it was 12 months that the price covered. So now we're going to check info, and you can see here that the price date is the date time, the ID is an object, and everything else is a float. And now what we're going to do is we're going to use group by to find the variances of the dates from the difference between the price in December minus the price in January of the previous year. And so this is the code to do that. So monthly price by ID equals price df dot group by ID price data dot agg So price off peak, see there, mean, price off peak, fix, mean, then reset index, and get January and December prices. So it says January prices equals monthly price by ID dot group by ID first reset. So that means that you're getting the first row of data. And then the December prices equals monthly price by ID dot group by ID last dot reset index. So that means you're getting the last row of data. And then what we do is we calculate the difference. So diff off equals PD merge, December prices dot rename columns, price off peak there, December 1, comma, price off peak fix, December 2, and then Jan prices dot drop columns equals price date on ID. Diff off equals off peak diff December January energy equals diff off December 1 minus diff off peak price off peak there, and then diff off peak diff December January power equals diff off December 2 minus diff off price off peak fix. Diff off equals diff off ID off peak diff December January energy, comma, off peak diff December January power. And here's your data frame that it created. So it gives you the ID, and then it gives you the two columns of data, which is off peak diff December January energy and off peak diff December January power. So now what we're going to do is we're going to do exactly the same thing, but we're going to be checking the price. So we used a different, so instead of using price off peak there, we're going to use the price peak. So the first one you were checking the difference between off peak, and in this one you're going to use exactly the same code, but the same code, but you're checking the peak prices. So whenever you do all that, again, you have your ID, and then you have two extra columns, peak diff December January energy, and then peak diff December January power. So now we have a difference between off peak prices and a difference between peak prices. So we're going to merge diff off and diff peak. Price diff equals PD dot merge diff peak, comma, diff off on ID. So you're going to merge it on the ID. So now we've got the 4 columns of data. So now we're going to merge the client DF with price diff. So we merge, and we're going to merge it on ID. So when we merge it, you can see that these 4 columns of data are on the end of the data frame. Now we're going to binarize variance of prices. So I put a binarize right there. So if the difference was greater, well, you don't have to, but if the difference was greater than 0, then you get a 1. Otherwise, you get a 0. So we binarized everything. So now we've got these binarized peak energy, peak power, off energy, off power. So we binarized that. So strictly speaking, we could actually drop the peak power, the off power, the peaks and the off peaks, strictly speaking, because we've binarized it. So that's something that we could do. Something that I could do. And so now I'm going to drop all of the columns that are object columns, but I'm thinking of dropping these 4 columns here because they're not needed once I've binarized the data. So I might do that to see if I can improve my score. Now we create a heat map, and then when we create the heat map, you see that some of the columns have a high correlation, and then so you can see the correlation here. But what I did was I didn't drop any of the columns that had a high correlation, but I could have. And now we're going to use TensorFlow. So we import TFDF, which is TensorFlow Decision Forest, and we install that into Google Colab. And then now we import the libraries that we're going to need. We're going to import TensorFlow as TF, import TensorFlow Decision Forest as TFDF, and you can see that we're working on TensorFlow 2 version 2.12. And now what we're going to do is we're going to use sklearn's train test split function to split the data set into training and testing data sets. And then the next thing we're going to do is we're going to convert the pandas data frame to a TensorFlow data set, and churn is your target or your label. And now what we're going to do is we're going to use random forest with TFDF. So model equals TFDF.keras random forest, and I said verbose equals 2, and then model fit train DS, and so it's verbose, so you get all this information. And then we check model summary, so you get all this information on the model summary. So we're going to compile the model, and we're going to check for accuracy, and we're going to evaluate the model as well. And so when we evaluated the model, we evaluated it on TestDS, and it has an accuracy of 89. Now we're going to do predictions on the model. So you can see that we've done the predictions. We're going to check for the unique values. So 0, you have 2,911, and 1s, you have 11. We put it on a confusion matrix, so all the 0s were done correctly, and you didn't get very many 11s done correctly. So that's something that needs to be improved upon. And then I created a data frame where you can compare the actual values against the predicted values. And one thing that I will say is I used several different models other than random forest because they wanted us to use random forest. But I wanted to see if I could get a better level of accuracy with using different models, and then I didn't get a better accuracy using different models. I used a deep neural network, I used gradient boosted trees, and definitely I used those too. So that's it. That covers this code review, and when I finish this code review, I'm going to go delete those 4 columns, or drop those 4 columns, and see if that improves my accuracy. Because you don't want to have too many columns of data, and the reason why is if you have too many columns of data, then it just generates noise. So that's one thing I will do, see if I get an improvement on my accuracy. So thank you so much for watching my video. If you like this code review, please like, subscribe, and share. If you want to be notified whenever I make a code review or another video, please tap onto the bell button next to the subscribe button, and you will be notified whenever I make a video. So thank you so much for watching my video again, and I look forward to making more code reviews for you in the future.